this is working. Yeah, he's already tried. It doesn't matter. Okay, so shall we do a little bit of a recollection? I'm audible? Alright.
So, what did the KSH paper actually say? What was its major contribution?
Its major contribution was the error rate and the convergence time. The convergence time, the amount of time to train and get to a certain level of error rate, and the final level of accuracy that was way beyond what one expected from machine
How
learning.
did they get that? If you can put it into some small word, if it is possible, what is it that they did differently so that they were able to achieve what no one else was able to?
Yes, so their model, the neural network model, and I'm going to get to that now, working concepts in AI. Once I get to that, it will be easier for me to explain. Had many more layers, and the training data set was much bigger than previous. So that was a major difference. So earlier, people were trying with smaller models. This on the next page, the number of layers was less, and the training set was smaller. With them, the model was deeper, and the training set was much larger. And today we are at a point where we have the entire plethora of those of you who are familiar, AlexNets and ResNets, which go to ResNet 1K. We have thousands of layers actually in between, much beyond what a single GPU, even the high-end ones, can hold as an aspiration. So sorry about that. We'll continue on this now. So we'll just quickly do a recollection. And I'm sorry, at times you may feel, some of you may have a very high expectation as to, we were expecting some more technical details. Tell me about the layers of AlexNet, dissect AlexNet for me. We'll do that. There are other avenues where we do that. The entire reason this kind of a seminar exists, tutorial exists, AI in a day, is to achieve that target which we call AI for all. There should be AI understanding for everyone. And that, I believe, is the way we can move forward as a nation. I'm sorry, I'm not trying to say this in a very big way, but even at a global level, not being overtly nationalistic. So even at an international level, at a global footing, we as humans should progress. So going back to our recollection, what is AI? We had these nice things, a talking robot, a thinking capability, Sophia, cloning human intelligence, learning as a capability, HAL, 2001, A Space Odyssey, the famous computer from there. Then the movies like Star Wars, Ravan and all, and we realized that we can actually talk about those capabilities with 4 fingers on our left hand. And if you are a left-handed person, use your right hand, and then for the main, how do you make that possible? Use your left hand, depending on your handedness. So we should be neutral per se for anything that's not common across the entire population. Now, what are the things? Let's just recollect from there. Speech, vision, all the other senses. The reason, I'll tell you the reason before we move on. And then knowledge and problem solving. Why did we not touch emotions and creativity? That's for our friends here, those who are into research. That's for you to research and bring it down into your 5th finger and maybe go beyond how many fingers are there in a hand. But for now, we stick to that because emotions, creativity, computers are far behind in that. If you're really worried about your human level job, figure out whether you're using your human faculties as much or not. Whether we are using, not just you, whether we are using our human faculties enough or not. If it is just rote learning and replicating, then probably, yes, computers will do better. They've been doing better at numerical abilities. The original term computers, if I remember, it used to be people who would sit down in the back offices and do calculation. Auditors' offices or accountants' offices, maybe mathematicians' offices also calculating logbooks and all. And they were actual human computers. If you go to on Wikipedia, you'll find something about that. And today they have been replaced by digital computers. It's very likely our human capabilities that do not use the human faculties will not survive the test of time. So I often have my medical interns or medical students come up to me and say, so will our profession survive the way you're trying to bring AI into healthcare? I said, what is it that you give your patients? We give cure. I said, okay, maybe you really give cure? Show me a prescription where you've given cure. I said, no, sir, I wrote the diagnosis and medicine. So I said, the nearest you came to was giving diagnosis and medicine. Cure was not in your hands. What did you give? What else did you give the patient? I said, fine. I went to medical school, never completed it. Whatever was the reason, I dropped out. I went back into job. If I give that same prescription, and let's say it's something that I understand and touch wood, I'm not doing anything wrong, will the patient be confident? No, sir. So what did you give the patient? You gave that patient the human touch. I was trying to bring up a few AI faces and get this device to talk. They're all refusing. They say, we are not going to cooperate with you today. It's probably the beginning of the AI revolting against humans. Anyway, so the end result of that conversation was, are you giving your patients empathy? Show me one system, one computer that can give, is capable of giving empathy, is able to feel together with the patient's emotions. And trust me, my friend, that the next thing we should go is go off to the Himalayas or wherever you like, sit down in meditation and take care of ourselves. That's not happening anytime soon. Even with the technological singularity, that is not happening. Alright, coming back. So we have these four things. Now how do we make that happen? Quickly, speech, vision, analytics or sensors, and knowledge. Why do I do this ordering? You have to look at it from a very information theoretic view. For a few minutes I'll wear an engineer's hat. Information is a stream, it flows. We know from our information theory there is a probability of the symbols that occur in that stream. I'm not going into the details. Our right engineers here understand, and we have lots of senior people who can teach me a lot of things about that. Every symbol that occurs in your information stream has a probability. That's the way the keyboard letters are organized. The probability of hitting a character, it was put on top, and the QWERTY, people argue against it. The characters that are likely to appear on the top, I believe the character with the highest probability in any text stream is E, and then comes in the other vowels, etc. So your probability of the symbol occurring, it's called the entropy of that entropy content. So that's about information theory. How does information flow? Information flows, in the case of image, as frames, but static frames. I can take a picture and have enough information in that picture. If I take a picture of this room, from that picture I can recognize you. I can recognize the event. I can recognize and count the number of people. The same, does not hold for speech. If you think of it, pictures, and let's be ingenious here. Frames, repeat rate of FPS, number of frames being repeated. Speech has a different characteristic. It is a linear stream, but there are frames in speech. How is there a frame in speech? We have to go into linguistics here. Sorry, I will be taking you a little bit of a roller coaster ride, because the next part is appreciated better if we do this. There are frames. What are the frames? The frames of reference. The frames that form the basis of OP. There was this frames theory which went on to become the object-oriented theory. The frames of reference, frames of mind. So there is a contextual frame in that. We all know the grammatical frame that exists in a sentence. The SVO, subject, verb, object, SOV frames that we say. Every sentence has a subject and an object. Excuse me. So you talk about it, there's a noun phrase, there's a verb phrase that forms into a frame. It's a little difficult, but then if you think of it, speech is flowing. Images, we all know it's a frame, right? It's a rectangular frame. We all agree it's a frame. Speech is also a frame, but that frame is of a dynamic characteristic. That frame has a depth of context. Therefore, speech is slightly different from image recognition. It needs context. On the other hand, I have put all the other senses together because most of them, I will not say all of them, most of them come without a frame of reference. If the temperature right now in this hall is, it says 18, that's probably the set temperature, but it's 22 degrees. It is 22 degrees. What is the frame of reference to that? At the most, you can say AC is on. That's a very little depth of context. Typically, all of these sensors, and we all from our sensors-oriented, instrumentation-oriented backgrounds, we know that most of these sensors at the end of the day give me a digitized value. All of our ADCs and all put in the line, put in the queue, all I get is a digitized value that will come in as a stream. There may be some sort of a grammatical framing that needs to be done, and that is what we are trying to do when we try to find patterns. What are we trying to do? We are trying to find that frame of reference in that series, in that stream, when we try to do predictive analytics. I'll not go into that school of thought, but right now, but ultimately they are just numbers they are throwing at us. Temperature is a temperature, taste is a taste, touch is touch. More or less. All of them come into the third finger, third category. Excuse me. Along with that, there are other sensors. Why have I put IoT and analytics? I should have written sensors over here. Why I put analytics with that? There are other sensors. The other sensors are like the Sensex, share prices. What are they ultimately? They are numbers. They are a time series of numbers. If I go again a little bit more deeper, I'm getting a linear time series, a constant linear time series, probably an ergodic system, a probabilistic system. I would not go into these terms in a different audience, but I believe just to convey what I'm thinking about, a system which has certain hidden variables driving its probability, driving the entropy content of the information that is generated out of the channel. Share prices fall in that same category. What else? The recent fiasco about a lot of data being used to drive elections, unfortunately, falls in a similar category. All of that are number crunching. All of that goes under analytics. Whether machine learning suits that or not, we will touch upon that. It's not a fit-all solution. Where do you use machine learning? Where would you go for a statistical solution to all of these problems? I'll try and touch upon that. And finally, of course, these are, as we call it, the sensory functions, the outward-looking functions where you get a physical number. You get a number. Number is not physical, but you get an abstract number, a specific number. You go to a higher level function of the brain, higher level function of cognition, knowledge, learning, recognition, and then the things we are not targeting, emotion, creativity, etc. All of that I put here as knowledge-based systems, problem solving, and higher functions of the brain. So essentially 4 things. Quickly, and then we close the slide. Speech, vision, sensors and analytics, and knowledge. If you get these 4 things working in AI, we agree that AI is successful. How do we make that happen? And that is what I have reserved your right hand for, and that is working concepts in AI. Excuse me. All right. So when we started, we had spoken about the perceptron. We spoke about how how we work with our neurosciences friends, and we understood how the brain was organized. We took that into our modeling. We made neural networks. Then we went into the big data phase, and we got them to train. All of this is good, but how long does it take you to implement an AI? Now, I cannot make a claim today in this session. I would request all of you to please continue to be on the Facebook page that I mentioned. Some of you may not be on FB. There is a Slack environment, Slack channel also. So out of Slack and Facebook, choose whatever environment you want, and ensure that at the end of this session, beyond these 3 hours that we are spending here in this hall, ensure that you know how to get this type of AI to work with the videos we have and the online help we give you. Now, how long does it take you to implement an AI? I will give you real statistics. For my project, my degree project, I made a robot that would take voice commands. Speech API from Windows, a little bit of neural network for learning and image recognition, robotics, whatever I could do. That was not the days of Arduino and all of that. I remember I spent a lot of time just to make the voltage controllers, the drivers for my motors. Because driving that entire weight on the robot, it would work. I add 2 more devices, it would fail. Another 2 devices, again it fails. So ultimately, my partner, my wife, she's a doctor. She said, Abhishek, I think what you're doing is you're placing them directly on paper, and a very bright person, brighter than me, of course. And then we put it on a different type of a material, mounted it on a different material, and it survived. So going back, it took me around 4 months, and the robot would do. Find me the red ball, forward walk, left turn, 2003, 2004 and all. Speech recognition was from SAPI, but beyond that, the text and all, SAPI is speech API from Windows. When I went in for the evaluation, the professor told me that this is good, whatever is the content because of that, but also because of the time limit in which you've done this. You've done this for your degree project. The last time someone did this for me was a PhD student, and he took his entire PhD time to do that. Nothing wrong against him. He was doing it in the late 90s. It took him 3 to 4 years to do something similar. End result, I don't know. Today probably what we do in one afternoon will have a much better end result than what I had with my robot in terms of speech, user independence, etc. So how long does it take us to implement AI? 4 years, 3 months, 3 hours. You see the exponential scale over there. What has enabled that exponential growth in the speed with which we can implement AI? Very different from big data. The answer is, going back to engineering, and we love to do that, the crux of engineering problem solving, and this is what I tell, I find it probably I'm skipping my mandate when I speak in front of such illustrious people, but for my younger friends there, I say, and I talk to audiences that come from different streams, different disciplines, medicine is a license. I may know medicine. Even after I quit medical school, I continued my studies and I use it for research. That understanding, I don't practice. Even I'm qualified psychologist, but I don't practice it. I practice as an engineer. But it is a license. You get a license to be a doctor. Lawyers, bar registration, again a license. Auditors, license. Engineering, unlike all of these, with all due respect to our effort at our studies and qualifications, sir, even though there are registrations around the world, engineering is a state of mind. You think like an engineer. And we often hear, right? Someone tinkers around and he's an engineer. Of course, every tinkerer is an engineer. And the crux of engineering, I believe, is about reuse. You have a solution, you reuse that and get it into another configuration that has another value added, gestalt. The whole is greater than the sum of its parts. So you add in another feature set to that. What has actually helped enable this exponential growth is the engineering has improved. And what has improved? We now have ready-made libraries from where we can pick and place components using the terminology from electronics, I would say. We can drag and drop components probably in the software domain, I would put it. Because to me, AI is not all software. As we go through, I'll tell you why it should not be software. I will also talk about a very different form of AI today. A very different form of AI, and I will have to keep track of time for that. We today have frameworks for doing AI. What is a framework? Imagine, and how many of us still do programming in C? I don't know, do they still teach programming, C programming in colleges? They do. Alright, so for those of you who have learned C programming within the past 4-5 years, what if you were to recreate the entire library of functions, right from our initial input-output functions? Every time you wrote a program, you had to recreate it. How long would it take you to write a simple hello world program with some input? You have to go. Okay. I typically would go and challenge my students, go ahead and tell me about the interrupts. How do you go and generate a keyboard interrupt? You go and trap your interrupts. You go and take care of your stack overflows. You take care of your buffering, etc. All right, I don't want to talk about engineering details here. But what do? Scanf, Cin. Not even that. Open a Visual Studio, drag and drop. You get a direct data connection built in. The same thing is done by the framework. What do I need for my neural network? I need the model of a neuron. Let's say perceptron. But there are more models. A lot of people are researching just the model. When you say model of a neuron, see, some of the terminology will be a little confusing. Please bear with me. Typically, model means the entire neural network. The neuron, the function of the neuron, the activation function defines the neuron. So when you choose the activation function, you go to the library and hundreds of activation functions are there. Starting from your linear activation function, you also have ReLU, half-wave rectification, which is part of most of the major image recognition neural networks that we build, most of the image recognition models that we build. Not just that, organizing them in homogeneous and heterogeneous layers. Same type of neuron in the same layer versus different types of neurons in the same layer. We get different types of layers over there, available in the framework. Now imagine, if I tell you, before you start writing your chatbot, please go and start studying neural models. You have to get a master's in the activation function of neural models. Once you get that, probably when you come to me for your PhD, I'm sorry sir, but when you come to me for your PhD, we will talk about putting them into layers. Probably our grandkids will have something close to what Alexa does today, if that was the case. But we don't do that. We just go and pick up the layers we want. Alright, you take the layers, how do you organize them? That's a research in itself. People research it at every level. You take those layers, people know in what order they are to be used. That comes out in all of our research journals. All you do is you get a fresh paper today which says, alright, probably someday I will have a network by my name, AbhishekNet. There's AlexNet and ResNet, why not have by my name, ACNet. I love to be called by my initials, ACNet. Let's say you're using ACNet and it is published. Assuming it's in public domain. All you have to do is figure out what are the layers, what are the interconnections, take a very simple framework. In that framework, write a text file and say layer 1, convolution. Layer 2, softmax. Layer 3, pooling, or layer 3 pooling. Layer 4, softmax. How do you organize them? Reorganize them. Done. In 1 hour, you can have that model implemented. What would earlier take years, not just months. So the first thing is the framework, which has a lot of reuse built into it. Model, of course, research has increased exponentially. We talk about the fourth paradigm in research, which is again data-driven. We look at existential proofs today a lot more, which are accepted by the publication, by the research community, which were difficult even when we were in college, just purely based on existential data. Papers probably would not be accepted as much as they are accepted today. You have an existential proof, all right, depending on what our affiliations are, probably they will accept that result. And most importantly, where this guy comes in, ImageNet, data sets. We were trying to train AI with small data sets which we were generating. Although big data has happened, there was another thing that happened, which was the entire internet revolution, and then we have this internet of IoT session and all of that coming up. So internet, like what is ImageNet? ImageNet is a collection of millions of URLs. They don't even give you the data. You can get a downloaded version of the data. They will give you URLs. You go and fetch the images from the URLs. These are all publicly tagged images. So I'll tell you what tagging is. When I'm throwing terms, I'll try and go back and then ensure that you understand the term. So these are the three things that work. So these go onto your right hand. What were the four things on the left hand? We had speech, image, analytics, and knowledge. So to implement that, and in the modern way, you first need a framework. That's your right hand. First finger. Your second thing you need is your model, an appropriate model for the task at hand. The same model does not fit everything. And the fourth thing you need is the data set. You can be researching, working on either of these, or you could just as well be an engineer. There was a time when they said Unix is for computer scientists. We grew up feeling very proud we could do Unix. Very frankly, today I find it a little awkward to believe that someone does not use Linux even though it comes free and is such a nice platform. I'm not advocating against or for any other platforms, but just as a personal opinion. Screen's off for a second. So quickly ensuring that we have a good coverage. Machine learning was about fewer layers. Deep learning is applying deep learning methodologies is essentially more number of layers. If you hear some very senior professors, I remember at a December 2016 meeting, some of you might have been there, sir, a very senior professor who's kind of the father of neural networks per se for us, many of us in India. He said that this is not really deep learning, and he had a very valid reason for that. But for us, deep learning is deeper number of layers. You understand that every neuron has a function which decides whether that neuron is on or off. That is called the activation function of the neuron. We move on. We've given you enough things for your left hand and your right hand. Now, there's a little bit of a challenge because usually what we do is, at this point, we get to hands-on. Now, we are not really feasible to get into hands-on, and the flow will break. We also don't have enough time. So what I will do is, at least another half an hour, I will make it a little didactic. I will continue to talk, and then we'll make it an open house for the last half an hour. And let's move on to the next few topics as to which would be of interest to you all. How would you go about doing this?
You can at least talk about the various platforms that give us
the hands-on things. I'm trying to look for just videos that actually exist. So if you keep following up on this page, there will be hands-on videos that will be available. That's actually a good suggestion. So let's do that. So what are the okay? What are my face? I'm sorry. So this is what we will do. Let me talk you through it. I don't know if this works. Thank you for being a nice audience. You've tolerated me for the initial part of the day, so hopefully you'll tolerate me through this. I want you to do this once you go back, and you can take notes. It will be available on this page, and if there's a method of communicating, I will try and communicate with the organizers as well so that it goes out to you. Start out with a Ubuntu 1604. image. I'm rubbing this portion. And it does not take much time to get started. Those of you who have cloud accounts, who have cloud accounts, infrastructure cloud, you can create a Ubuntu 16.04 image in that infrastructure cloud. I cannot, infrastructure cloud are people who provide you images of a virtual machine on the cloud. I don't want to name any specific corporate, there are some nice ones out there which support it. So what you start with is Ubuntu 16.04. Very specifically Ubuntu 16.04, don't choose a later version because the way Ubuntu release cycles go, they have these versions labeled as LTS, which stands for long-term support. The next long-term support, if I understand them correct, should be coming out this month, 1804. 04 is the month and year is 18. So when that comes out, probably we will all try and start supporting that. As of now, those who support AI platforms, what do we support? Frameworks. You build your models on top of that and data sets come, they're common across platforms. So you use 1604, which is a long-term support, and on top of this, you ensure you have apt-get working, and with apt-get, you use the command install. All of this is there on that page.
Just a moment while Echo Dot reconnects.
Did it have a connection? So, apt-get install, and with this you have to install git. These are skills that you'll have to pick up. With that, you have to install Python 3, and you have to install Python 3 pip. And the framework we all will be using is called TF. I'm very sure in today's world, many of us would know what is TF. Any of us here? What framework is TF? TensorFlow, yes, I think that's TensorFlow. So it stands for TensorFlow. Initially released by Google, now a community effort, and still supported by them. Not that everything they do is great, but I think they've done a great job with TensorFlow. So we will install TensorFlow, and how you go about installing TensorFlow is after you've done apt-get install git Python 3 pip, you simply give a command pip3 space install TensorFlow. It's there on this page. You can just go back to the visitors comments on this page. I request those who are successful in doing things to post how they did it. Ensure using the appropriate commands again on this page that you are on version 1604 because many of the libraries will not otherwise work. Now trust me, what I told you in one sentence right now, pip3 install TensorFlow, till around a year back, 1.5 years back, would take a lot longer because I would have to tell the audience how to compile TensorFlow by themselves. Now this will work on the x86 platform only. If you have a more esoteric platform, a better platform, worse platform, no, but a different platform which is not x86, you will need to go into installation from the sources method. If you're facing challenge there, feel free to. TensorFlow has a nice community. If you still have challenges, we can start off within this community. We can have some information as to what is the platform you're trying, especially if you're looking for some graphics acceleration. Now, after you've done that, will it work? pip3 install TensorFlow, will it work? Yes, I know. Sorry. So, will it work? It will not work. Why? You need a few more things. I got so much stuff. I got this, I got everything on my computer table was in my bag today morning. But still I forgot my dongle. I was expecting my mobile phone hotspot to work, it did not work. Anyway, so that's technology, it will not work. Why will it not work? Because TensorFlow, and specifically the framework, not TensorFlow by itself, the specific models that I would like you to get started with, they depend on a few other libraries, Python libraries, that are not directly installed. So you would then have to go into Python 3 and install libraries like NLTK, Natural Language Toolkit. Alright, this chart is becoming pretty. NLTK, and in NLTK you may have to download the data set. You have to download the data set for NLTK, and beyond that you will need TQDM. So Ubuntu, apt-get install JIT, Python 3 pip, pip install, this is with pip install, TensorFlow, after that Python 3, inside the Python 3 environment install NLTK, dataset, NLTK with the dataset and TQDM, and then download a project called DeepQA. How many of you know of Watson? I'm not talking about Watson here, and what I talk about is not Watson technology, but there's a similar technology in Watson which is called DeepQA, and this is somehow related or derivative probably, but I don't know, and no warranties onto that, just a caveat. So download a project from GitHub called DeepQA. Again, these links will be there on this page. If we face issues, we will solve it out. Post these, and I try and conduct these seminars at least once a fortnight. So at the next time, by that time, you'll get the answers. Install DeepQA, and in DeepQA, you will have the ability to create your data set. Now, talking of that, what will be your framework in which you will create your model? You will run your model. It is TensorFlow. What will be the model you will be running? DeepQA is the project. There is a model called LSTM, long short-term memory. Those of you who may be familiar with that. It will be used for natural language processing in DeepQA, and in that, the data set that is there built in will take you on a regular laptop. It will take you around a few days to train. Versus there is something called the lightweight model. You can go ahead and train that. Now, I'll end it at this because this monotone without an example will not hold much value. This is what we would have spent the second half. We will do that online. Let's put it as such. Let's move on. If you're good, we'll come back to that. If you have questions, you can write to me and all. Now, we said big data, and big data got accelerated. Big data allowed us to deal with a lot of extra size, voluminous information. How did that work? I was talking about divide and conquer. What is divide and conquer? We are around 60, 70 people, probably around 100 people in this hall today, and we want to add 1,000 numbers. Very simple. We divide the problem. Each of us sums up 10 numbers. We pass it around, some extra overhead, and the problem gets solved in much smaller amount of time than one person sitting down and adding all the 1,000 numbers. Probably with humans, we also have the human error put in. So we went for distributed computing, etc. All of that was there. We've spoken about that, cluster computing. What came in then was the GPUs. We were trying to create a system which had more and more number of process elements in that, compute units. I'll use more engineering terminology probably, so it's comfortable with that. Typically, when we look at a computer,